Hi, everyone. Welcome to this edition of the AI Monetization Podcast, where we speak with industry leaders on what business outcomes they are seeing with AI. Today, we're delighted to have Ben with us. Ben uses Gen AI to accelerate and simplify experimentation, and he has spent a lifetime focusing on advertising and marketing measurements. Ben is currently the lead economist at Amazon, where he focuses on experimentation and AI-powered economics to solve business problems. Previously, Ben was a data science manager focused on experimentation at eBay. Previously, he built out the Galvanize Bootcamp campus out of Seattle. And then previously, he was a principal data scientist at Convoy, focused on the freight industry, where he was working on important problems like pricing, forecasting, etc. Ben has a PhD from UCL and undergrad in physics from Princeton. Ben, thank you for taking time to do this. Welcome to the show.
Hi, Benny, and viewers. It's great to be here, and I'm excited to talk to you about some of the clever and not clever things I've done so that you can learn from my experience. I also need to say that all the opinions I express are my own and not those of any employer, past, present, or future. And I would just like to clarify that I am the lead economist for the one of the marketing measurement teams at Amazon. So it's a central scientist team. One of the great things about Amazon is that there are hundreds of economists. So there's a great ferment of thinking about the best ways to do things like AI and measurement in practice.
Thanks, Ben. So Ben, given your academic background in economics, right, how does your worldview on experimentation and marketing and advertising like get shaped with your kind of background in economics? How do you bring that
Yeah,
together?
that's a great question. And so uh, I'd like to think that this was a really clever thing I thought out, but I happen to focus on three fields that were really perfect for this work. And when you do an economics PhD, you focus on several fields, which are the sub-disciplines of economics. And I focused on industrial organization, which is the study of how firms and consumers interact. So things like pricing and demand and supply and market structure, that kind of stuff. And a lot of people from that field then go and teach at business schools in quantitative marketing roles. I focus on applied econometrics, which is the kind of evolution of statistical thinking for solving economic problems, and then also computational methods. And I was really fortunate to get to do some work with Ken Judd, who's at the Hoover Institution on War, Revolution, and Peace, and one of the top computational economists in the world. He literally wrote the book. So uh, it turned out that that was just kind of the perfect background because I understood this interaction between firms and consumers. I knew how to think about optimizing something like my marketing spend across a portfolio, and I had the background to do measurement. Now, I came from a structural econometrics background, which is from people like someone like Jim Heckman, who's my academic grandfather, where you would build like a behavioral model and then try to estimate like the deeper parameters, which is interesting because then we can understand the impact of policy, like changing pricing or some policy to say prevent smoking or teenage pregnancy. And those of you who come from computer science will know this from Judea Pearl, who has one of the approaches to measurement, which is the structural modeling. And there's another approach which is very popular right now, which is has grown out of like work by people like Don Rubin, who's a statistician, on potential outcomes. And we see this a lot. It's really helped revolutionize the field of measurement for everyone because and is a key part of what's called causal inference. And so we're trying to not just do statistics, but understand actually if A caused B. So instead of looking at correlations, it's understanding how much impact some lever, such as spending more or less on marketing, will have. And so this is super useful for businesses or policymakers because you want to actually understand these linkages so you can have the right interventions.
Okay. And throughout your career, Ben, you kind of emphasized the importance of um, asking the right questions before stepping in experimentation and all that. So, do you have any guidance or best practices on picking the right problems to solve, asking the right questions?
Right. That's the $100,000 question. And I think the first thing I always say to anyone working on a data science problem is that it's really good to use a workflow like CrispDM. And that's the place to start because CrispDM will guide you throughout this process. And there are other evolutions from it. So you start with the business question, which is just so crucial. And that involves like talking to your stakeholders and really understanding the problems. What do they need to solve? Understanding the business. And you may not, even if you're the most clever and intelligent person, even with a Nobel Prize or more, just sitting in your room, with books and papers and computers, you may not be able to figure this out. You really need to go talk to subject matter experts and understand the business. And so one of the things we talk a lot of at Amazon is working backwards from the customer. And so an economist would know this kind of as backwards induction, right? So we understand like what's important to solve and how would you measure success. And another part of this is there's a wonderful econometrics book that was popular about the time I was finishing my PhD by Angress and Pish called Mostly Harmless Econometrics. And they say there are basically two kinds of problems. There's what they call a FOOQ and what's called a FAQ. And so a FOOQ is a fundamentally unanswerable question, and a FAQ is a fundamentally answerable question. And so a FOOQ would be something that you could, even if you had ideal data, you wouldn't be able to answer it. Whereas a FAQ is something that you can answer. And maybe you're in a situation where you don't have the data you need to answer it, but you could go out and collect it. And so you might start answering this problem and realize there's some key aspect of customer data or customer behavior that I don't understand. I need some extra data. So maybe you can add some demographic data or, figure out how to collect that data. Or usually at Amazon, there's some other team who owns that data and you go talk to them. If you're a big company, often there's that data and it's just figuring out how to get to it. I think a lot of people too, when you're outside these companies, you think that they have infinite data, but it's often much less organized than you might think. And I mean, I remember when I first went to Amazon and I had to measure the impact of marketing on books, it wasn't like just writing a SQL statement where it was like, select sales from books, you're done. It was like a 2 or 3 pages of SQL because there were 5 or 10 ways something could be a book. And so you even as like a person who knew SQL, I wasn't going to figure that out if I didn't go and become friends with a business intelligence engineer or a data engineer. So, and then the last thing I'll say on this is that it's really important to talk these things through, and that the more diverse our team is, the better our decisions. So like, if I'm on a data science team, I want to have men and women and people from different backgrounds. And so that we can come to like a better decision. Like, when I got my first iPhone, I was a postdoc in the University of Chicago, and I go outside to take a picture of my cute dog, but it's winter in Chicago. My phone stops working. And I go back to the store and I'm like, hey, my phone doesn't work below zero or freezing, 0 Celsius, 32 Fahrenheit, depending on where you are. And they're like, yeah, read the fine print. Like your phone doesn't work. We don't guarantee it. And it's like, this phone was built by people in California, and maybe it never occurred to them that people who live in colder climates would want to use their phone in winter. And so like, those are the kinds of things you want to avoid. At Amazon, we call that like seeing around corners. So it's really hard sometimes to identify these, but sometimes it's very clear. And so as part of that too is thinking things through to success and the right metrics. Mm-hmm. So like a good example of that too I can give you is like, I've been thinking about this a lot, is that right now we want to measure where in my central science team, we measure both performance marketing and brand marketing. And these would be different problems, and so what might be the right metrics to measure variable marketing would be different than the metrics to measure brand marketing. They happen on different timescales. And, like if one campaign didn't happen, it might not have a huge effect on brand marketing because that's built up over many years of, advertising at an appropriate intensity, and maybe things like reach are more important. Whereas something like performance marketing, that's much more transactional, and and I'll have data that I can directly attribute because, and again, the other piece of this too is like, how can I measure it? So with something like brand marketing, I may only be able to vary the spend at the like geographic level, like a city or even a country in some cases. Whereas with something like performance marketing, I can see that at the user or the item level of detail. So it's a very different problem environment.
Got it. Very interesting. And when you're talking to like a performance marketing team or a brand marketing team, which are probably not extremely technical folks, but very smart business folks, how do you decide on the appropriate level of sophistication or complexity of your analysis or model you're going to use from a time perspective and from their comprehension perspective? Like,
Yeah, and that's super, super critical. And when I first started at Amazon, I was really bad at this. I wrote papers that looked like journal articles. I used, LaTeX because it had beautiful math. And so I'd send them a PDF. It had an abstract, it had math. It was horrible. Like they couldn't edit it, they couldn't comment it. It was at the wrong level.
mhm,
Recently, we had to present a document to a VP internally about a marketing question. And we actually put it in an LLM and said, rewrite this in third grade English. And right, maybe that seems kind of cheeky, but we actually really did this and it made it better. And particularly at Amazon, we communicate a lot through documents. So going through many steps of editing to make it like simple and what we would call crisp, so that it's like easy to understand and it's so that you can make it is also important to make the right decision. And the better the document and the more clearly and simply you can explain it, the better the conversation you'll have with your stakeholders. So that's like a super important thing. So I think I'm always working to be able to communicate better. And another key part of that is having the right visualization. Like when you can explain the idea or the concept in one or two figures, maybe you understand it at that point, and you don't really understand it until you can explain it well and clearly to someone else. So like my target audience, it's depending on where I am. Sometimes I say, hey, I need to be able to explain to my mother. When I was at eBay, the persona we targeted was a brand new MBA who's just joined the company. And at Amazon, with something similar for like, this needs to be something that like a VP can read. It depends on the document, but typically, like if we're talking about marketing results or strategy, right? It needs to be something a VP can read. There's a super busy person. They're going to be smart, but like you shouldn't get bogged down into, I ran a Dickey Fuller, an augmented Dickey Fuller test to do such and such. Like that's why we think this is good. They don't need those details. You should be like, hey, we did a bunch of checks to make sure that this was the right methodological approach, and so that what you're presenting is trustworthy. And that's another key part of why simplicity is important, because you need to be, the work you do needs to be trustworthy to your stakeholders.
Yeah. Makes sense. And before we go into AI and experimentation, Ben, I was just curious, across companies, right? Are there low-hanging fruit experimentation things that people can do that people most often miss not doing? Just easy, quick wins in the experimentation segment.
Yeah, I think that a lot of it's culture. And so I think that, success in experimentation really depends on three things, which are culture, infrastructure, and methodology. And I often say to people, like, if you had perfect infrastructure and perfect methodology, but the same culture, would you make better decisions? And so a lot of the low-hanging stuff is really around culture and building a data-driven culture where we truly we make decisions based on data and not opinion. And there are times where opinion is all you have. Like maybe you have limited data or time and you collect the data you have, it's incomplete. And this is part of why, like CEOs are paid a lot of money, or, sometimes in these cases you would do what statisticians would call assemble a panel of experts. You have some kind of voting or horse trading, but like we want to have a robust culture where we can, it's safe to disagree, discuss ideas, and really make decisions on data. And there's this famous James Barksdale quote, something to the effect of like, if we've got data, like, let's go with that. If it's just opinions, let's go with mine. I'm sure I misquoted him, but the intent is there. And there's another part of this too, which is an idea from Microsoft of the HIPPO, which is the highest paid person's opinion. And so you want to be making decisions based on data and not being pushed around by the hippo because they've just got some beliefs, or analyzing the data and getting the result the hippo expects. And I've seen that happen where, like, very early in my career, there was a high-level executive who came from a direct mail background. He believed that direct mail would solve everything. The people who had analyzed direct mail experiments before me got 10% lift because they said the attribution window was months and months long, so that anything that happened after you sent out the direct mail for the next 2 or 3 months was all because of direct mail. And if you think, well, about a reasonable attribution window, which is maybe a week or two after the direct mail goes out, then there was no effect. And so I did a more data-driven and I think defensible analysis. And so I got no lift. And boy, was I in trouble, like in my first marketing measurement job. But fortunately, I'm not afraid to be fired. But there can be a lot of tension. And so having a culture that's healthy where you can disagree, and that's a great part about, I think Amazon, and part of why I returned is that, like, if you have data and science to back you up, you can make a case and you can have that discussion in hopefully a safe and productive way.
Oh,
that's one thing. And then the other thing I'd say is on the technical side, you should be doing variance reduction. That's something people struggle with. Some other simple things are, besides variance reduction, which is key, if you randomized at one grain, like the users, you should analyze at the same grain. Otherwise, you have to make sure you compute error estimates correctly. And so I see that's a very common mistake. Like, people randomize on users or items, and then they analyze on, like, user day or item day grain, thinking they're getting more observations. And so there are problems there because of serial correlation. Mm-hmm. And then the last thing is, on the internet, data is not normal. We often have heavily skewed data. And so you may have done good experimental design to determine how long your experiment should run, but you ignored the fact that your data is not normally distributed because of this long tail on the internet. And so you actually don't have enough observations for approximate normality, which means you can't trust your estimators. So you need to have another strategy or take more observations. But there are many other things we could keep talking about before we get to AI.
Okay, yeah. But so, getting to AI now, finally, in experimentation, right? Traditionally, what role has ML played, and what role is now kind of Gen AI playing in experimentation?
Yeah, so ML is super important in a lot of cases. Mm-hmm. I think one of the things that's really helpful is when you're thinking about your science problem, there's this great paper by Galit Shmueli, To Explain or to Predict. So if you want to explain something, that's one modeling approach. It's going to be more statistical, econometric. We're going to run experiments. We're going to do causal inference. And if you want to predict stuff, traditionally you'd use machine learning or a subset of that, deep learning, particularly for perceptual problems. And so where these have come together now is in this field of causal inference. And so now we're able to use machine learning techniques to help make causal statements, which is really interesting. So I might use a machine learning model to predict the outcomes for receiving treatment and the outcomes if you don't receive treatment. And I can then look at the difference in those to estimate what lift or impact would be. And so that's a really useful application, particularly if I'm in a situation where I can't run experiments, but I still need to make a decision. Within experimentation, it really depends on the kind of experiment, but mostly that's part of the reason we're doing experiments is because we've all heard this phrase way too many times, it's the gold standard for causal inference, because randomization should allow us to eliminate bias and then have simple statistics like a t-test to do our analysis. And so the better the data and the experiment we've been able to run, the easier the analysis should be. But when we have to run what are called more like quasi experiments, where it's not like users coming to a platform, it's like blunt marketing instruments like billboards or radio or TV, where I can only vary that at like some geographic level, like a city or a country, then there's going to be more scope for these machine learning methods, because I'm going to have a more complex analysis method than just, I randomize, I can do a t-test. because as part of that, I'm also trying to eliminate as much noise as possible because these are very weak signals. And so my ability to measure is basically the ratio of the signal strength to the noise. And so the more I can use techniques to reduce noise, you might also use machine learning for a variance reduction technique in the analysis. So there's something called Cupid, and then there's an evolution of it called QPAC, which are techniques for shrinking the noise. Basically, you could build a machine learning model to eliminate the noise you can predict, and that would help you reduce the noise. And so then you increase the signal strength, signal to noise ratio, which makes it easier to measure something, which means you can either detect things you couldn't detect before, or you can run your experiment in less time, which reduces the cost and helps you make decisions more quickly, both of which will help you get promoted.
That seems like a good outcome.
Yeah.
And how is Gen AI coming into all this today?
Yeah, that's a great question and something I'd love to see more of. I think it's still too challenging to run good experiments, particularly for the less technical stakeholders. And I think the North Star that I would like to achieve when I'm building or trying to improve an experimentation platform is that we can run an experiment without statistics knowledge and make a good decision. And so someone like a new MBA or UX designer, someone like that, they can run an experiment and then make a good decision and not have to know a lot of statistics or talk to someone like me who might bore their socks off by talking to them about nuances of significance and power and type 1 and type 2 error and false discovery rate and all kinds of things that really they hopefully shouldn't need to know about, right? So that they can focus on what they're best at. And so I think Gen AI comes in several phases. One, and I've built some prototypes or worked with teams that have built prototypes around these. One is standing up an experiment. I'd love to get to the point where you can, type your business question into something like, experiment, GPT or Claude experiment, and it then goes and stands up your experiment. And if you think about it, big companies like Amazon, eBay, they have large databases of all the experiments they've been running for 20 or 30 years. They have some kind of label. So it's possible to train or extract information from this if you've collected good metadata, so that we should be able to, and we built a prototype to do this at eBay where you could type in a business question and we could then stand up an experiment with appropriate settings like choosing metrics and other settings. And then as a human, you can just kind of review it. It saves you a lot of time. It's kind of like one of those old coding wizards, I guess, in Visual Studio, but powered by AI. And then you can, fine tune anything you need. You can run the experiment. And then as the experiment progresses, you can get help about other things like interpreting the results, so that, many of these, classic experiments like feature experiments, on-site experiments, those have a very standard structure and analysis approach. And so the AI can then help you explain what happened. And then at the end, you often have to produce a launch announcement to explain what happened, whether or not you're launching. Again, AI can help write those and save people a lot of time. It's also good because it helps share what people have learned or discovered more widely so that the organization can learn. And that's an important reason. We run experiments for several reasons. One is to measure whether or not something's better, but also to learn more about our customers or what works, like what kind of marketing is better or what kind of features improve the user experience, or reduce some other metric we care about, like bad customer experience or churn or product returns or people not checking out. So I think there's scope throughout the experiment lifecycle to make it much easier to use, operate, interpret experiments.
Got it. And when you say stand up an experiment, could you maybe help us understand what does that kind of technically mean, standing up an experiment? What's actually going on there?
Yeah, that's a good question. So if you're at a startup, it's very different than if you're at a big company like Amazon or eBay. And also, so the big companies like Amazon, eBay have built their own customized in-house experimentation platforms. Startups at a certain size may have purchased an external experimentation platform from someone like StatSig or GetEpo. Like those are two of the best in the industry right now. And, or it may just be something crude that you've stood up at home if you're very much at the beginning. And these tend to be like very engineering heavy. So let's start with the startup, the totally poor startup. You're building your own simple experimentation. It's kind of like some data science boot camp. You're doing it in a Python notebook. You have to figure out how to randomize and assign different experiences to treatment, like the blue button or the orange button, say, for sake of argument. And so then there'll be some randomization process, which is done using a cryptographic hash. So I'll spare you the details. So basically, you have to randomize. You have to have a way to split the traffic. So the easiest way to stand up these experiments is using something called feature flags that let you basically wire in this like split in the logic for what you get. And they're also nice because you can turn this behavior on or off with a flag so that it makes it safer to deploy and cheaper. And so the stand up then starts with designing your experiment. And then there's an implementation phase where something has to be wired into your code. And so that would be something like feature flags. Then you collect data, and then it gets analyzed, and then you make a decision. And so, it's somewhere Amazon, like eBay, the platform will do that. There'll be company-specific ways you put the hooks in your code. And as part of the stand-up process, there'll be some knobs you can adjust. And so the key things in standing up are determining how to adjust the knobs and then working with engineering to make sure that feature flags or whatever your own version of that is are wired appropriately into the code. If it's something like a marketing experiment, then it's a bit different. You're often work with the vendor, Google, Meta, and they'll handle randomization. And then you have some way of getting data that can involve clean rooms, which are a whole nother story. Sorry if that was a long-winded answer.
No, that's
hope that was remotely clear. I'm sure the Amazon VP would be not happy with my answer there.
The other thing I was curious about is earlier, before we started the podcast, you were talking about there's a ton of work happening at the intersection of economics and deep learning.
Yeah.
Could you maybe just help us understand what's happening there at that intersection?
Yeah, so there's a lot of really exciting work as economists learn how to use deep learning to solve problems they didn't know about, and other people in the causal inference space. So causal inference is a new part of this whole world of econometrics and statistics that's really focused on trying to understand whether A causes B. So if you move some business lever A, what's the impact of that and where would I want to set it for the best outcomes? And where deep learning is used is to help build these causal models. And one great example is the work of Susan Athey, who's a professor at Stanford. And there are two papers that come to mind. One was about called Career, which was they trained a foundation LLM on resume data to understand labor market transition. So how your career would progress and how you transition from one job to another. And historically, economists had tried to predict this just using data that we'd collected, things like their famous economic data sets for this, like the NLSY data set, the National Labor Survey of Youth, where they track people over time and send them surveys. But she and her co-authors had access to all this resume data. They trained a foundation model on that. And then they were able to fine tune it with the NLSY data. They used a transformer architecture, which was radical. That's the first time I know of someone using a transformer on an economic problem. And this allowed them to predict and understand labor market transitions vastly better than any economic model that had come before it. It was just a step function improvement. And so that was one of the things that really inspired me, that paper. I was like, I really, as an economist, I need to invest in acquiring the deep learning human capital, we call it human capital, and improve my deep learning human capital. And because these are just key tools I need. The other paper that I really found influential was by Farrell, Lang, and Misra. And they built a model with deep learning that was much simpler than a foundation model. And it basically allowed them to impose economic structure on a deep learning model so that they could estimate outcomes in a very flexible way. And they applied this, for instance, to the SNAP food support program in the US for people who are like homeless or very poor. And they use this to understand the right way to send messaging to this population to get them to enroll in this program. And it's surprisingly hard to enroll in this program to get food assistance. And like, you need a bank account, you need to fill out forms on a regular basis. And their marketing was so effective using this that they basically were going to bankrupt the government program because they had like such a higher response rate. I think they got in a little bit of trouble because they got so many more people enrolled who needed this that like was just depleted the budget. So they were able to estimate the right way to send this messaging in a very flexible but lower cost way. It's much less computationally intensive than training a foundation model. If you're going to do that, you're going to spend, hundreds of thousands of dollars and need real specialist help from your friends in the computer science department.
And, when I was going through your LinkedIn profile, I noticed this consistent feedback in your LinkedIn recommendations about how you're an inspirational boss and a mentor. What are your guidance and best practices on how you manage and inspire and get stuff done from your team?
Yeah, those are great questions. And so I tend to be almost pretty academic about that. And I think a lot of the best stuff I've actually learned from my wife. And one of the great things about COVID was having my office downstairs under my wife and getting to hear her talk to her people. And my wife is a designer. She's a successful entrepreneur, design leader, and she's got lots of woo. So she comes from the world of woo and art and creativity, and I come from science. And so we meet somewhere in the middle. And like, I think part of it just really starts from caring about people. Like, I really care about people and I enjoy helping them and I want to see them succeed. And particularly in an uncertain time like we live in, where there's all kinds of unhappy things happening in our world, it's really important to just listen to people and check in. And so when I joined the team I'm on at Amazon currently, we'd had a lot of attrition. There wasn't senior economic or science leadership. And so I really just started having one-on-ones and listening and supporting people, understanding where they were struggling, making sure they know that they have a resource so they can get unblocked, helping them develop the skills that maybe you're not taught in school, like how to deal with conflict, how to use your time efficiently, how to plan, how to choose projects to set yourself up for career success. So, wherever you work, you should have a leveling guide. You should make sure you're doing projects that help you tick off the boxes you need to get to the next level. And so just even simple things like spreadsheets can be helpful. So my wife was like a fan of using the Covey quadrants, so like rating tasks, is it important or not important? Is it urgent or not urgent? And just like thinking about all the stuff you need to do. So I set up a spreadsheet and you just put stuff in the boxes and it helps you know where you should spend your time. So you're spending it on the important stuff. So I think, but there, a lot of it really just depends on what each person needs at a time. So, and also, then the last thing I say is I try to show up and make it fun, right? We should be enjoying what we're working on. And if not, then we should figure out how to get to where we're enjoying our work. And so, like if you're doing data science and you'd rather be building houses, then you should figure out how to get there. But yeah, I think it really starts from listening to people and then helping them on their skills. At Amazon, a lot of that's around writing too. So like I've been recommending a lot to people who are trying to improve their writing that they read this famous book, The Elements of Style by Strunk and White. Super short book. So if you need to move your writing to the next level, you can read it this weekend. And then I guess I'd say the last thing is how you run meetings. I think running meetings it's really important to do that in an inclusive way because we want to hear from everyone, particularly junior people. And so a lot of that is making meetings safe. Often at a meeting, if I notice someone hasn't spoken, at some point in the meeting where it's appropriate in the middle or near the end to just say like, hey, is there anyone who hasn't spoken who'd like to speak? and making it often junior people are, even if they're right, they're afraid to confront more senior people and say,
Mm-hmm.
look, and saying to them sometimes outside the meeting, if you're not comfortable, like, I'm happy to support you. I've seen your work. We've discussed it beforehand. I'll back you up on this. And so they know they have high level science support. And that's a useful thing too. If you're early in your career, sometimes if you're dealing with high level people, you may need to recruit a high level scientist to support you, because in some organizations, there can be some real level to level circling like dogs.
Yeah.
I mean, I think and then just developing the basic skills, particularly for those of you who are new to the tech industry. There are books like Managing Humans, which are great about understanding how management and work is organized, particularly for scientists too. They don't understand Agile. So helping them understand how software is built using processes like Agile. And then the last thing I'll say, it's really helpful to pair scientists with engineers, because they both can learn from each other. And particularly at this intersection of data science or scientific modeling, it's kind of that Derek Jeter world where, if we can put them both together, then they have those Derek Jeter skills. Sorry to use an American baseball metaphor. We should probably be talking about cricket, but my knowledge would end at LBW. But putting them two people together, they're stronger, and because they can then build stuff, but with the right science. And so we do that so that the scientists write better code, and they're good citizens in the code environment. They're not checking in bad cowboy commits that haven't been, reviewed and written to appropriate style and other guidelines. And then the engineers understand the science that they have to express in code every day.
Mm-hmm. Yeah, I know that's very well said. I can totally see how team members like deeply appreciate a culture like this. Um, I have one final question that's completely off topic, because you mentioned a couple of times about the culture of writing at Amazon, right? Could you
Mm-hmm.
maybe just talk about, is that writing largely to just convey communication, or is it for your own thinking as well? And how has that culture of writing really helped? What does it do? Like, how is it different
Yeah.
from Slack and things like that? Yeah.
Yeah, no, this is a really, really important question. So I first became aware of the importance of writing really as an undergraduate. And I was
Mm,
really fortunate to work with this famous physicist named John Wheeler, who was a
mm,
disciple of Enrico Fermi and Niels Bohr. And so he was kind of like your ideal grandfather, but you could talk science with him. It was an amazing experience. But
mm.
he'd say to me, do you keep a notebook? You should. Fermi taught me that. And so, like, you can't really argue with that. So
Right.
getting, you know, it's really good. I'm like old school. I like pen and paper. I've got the old school notebook.
Mhm.
This and a pen. But in the digital age, right? Everyone's got their own thing they like, a Google Doc or whatever. But it's just really helpful to write down what you're doing and thinking about. And there are a variety of kinds of documents I think are helpful just in your personal career, like what are you doing each day, tracking your accomplishments for promotion. In terms of decision making at Amazon, there's a way we typically write that doc. You usually start working backwards from the customer. And the reason this has, and so let me back up. So if you call a meeting, you need to write the doc that goes with it. And if it's not a good doc or the meeting doesn't have a document, people may not attend. Everyone's busy, so we show up at the meeting.
Mhm.
And the meeting is as long as it needs to be for the doc. If it's a simple doc, it might be 30 minutes. If it's a longer, it might be 60 or even 90 minutes. And it depends on how many pages are in the doc. And so you show up, everyone reads the document. In the old days, like 10 years ago, they were printed out and there was like a stack of them on the table. And now people read them online and can comment in the document. And then, so we read, say it's an hour meeting, we read for half an hour.
Wow.
And then, yeah, so it's super intense. People engage with the material, and then we have a discussion about the document. If it's a good document, it means we'll talk about the ideas and the decision and the data. And if it's a bad document, we'll talk about how the document needs to be fixed. And that's a really unhappy situation, because then you're going to have another meeting and nobody wants another meeting in a week
Right.
later. So I really try to work with the junior people to help them write those good docs so we get the good discussion. And Amazon developed this culture because PowerPoint was such a sales tool. It tended to put people to sleep, and you didn't get all the minds in the room working together and talking about the ideas, whereas writing the document makes us engage with the material. And as you write the document, you come to a deeper understanding. It's just like teaching or explaining something. So that's like the main document that I see the most on a daily basis. But I'm in a central science team, so mostly we're talking about scientific questions. How are we going to solve them? How are we going to convey that information to stakeholders? Or how are we going to build the right things for our internal stakeholders who need to measure marketing? Another famous Amazon doc is something called the PR FAQ, which is the press release fact, and it's the ultimate working backwards from the customer document where we're going to release a new product, and this causes us, so we write the press release first, so it makes us think through what are the requirements of the product, how is it going to impact customers, what's the problem it's solving. These are really fun documents to write because it's kind of a celebration and people getting together and kind of ideating and making sure the product is positioned well. We talk to stakeholders. And so those are two very common documents. Another one is, like if something bad happens, like we had, say you had some defect in code that led to a bad outcome, you would write a document around that, which would be about understanding the error so we can eliminate it. It's not to cast blame. That's another important kind of document. So those are like three common documents, but the main one is the first document I mentioned.
That's
Did I
fascinating.
answer your question?
Yeah, absolutely. It's fascinating. We always read about it in public domain, what Amazon does, but this is great to hear a firsthand view on it.
Yeah, it was one of the things I was really excited about when I returned to Amazon because those meetings are much more effective. You know that you're in a meeting where you're actually getting work done because you're going to get to a better decision. And it's not somewhere like other companies I've worked where, it's more PowerPoint driven or people show up without a real plan and you have a like wandering conversation, nothing is decided. And then you keep having this meeting week after week after week. Like meetings should produce a decision and end. And maybe you need a couple meetings to get to where you need to be, but they shouldn't be endless. And if you're in an endless meeting, that keeps showing up on your calendar week after week, then it's good to understand why that's happening and fix the root cause.
Yeah. It's very powerful. Sounds like a very, very powerful instrument that more of us can do with. Ben, on that note, thank you so much. This has been extremely helpful. It was a pleasure chatting with you.
Yeah, thank you for the opportunity to chat with you, and I wish you and all your viewers success in their whatever you're building.